Let's configure a summary address on R1 and have that summary address advertised over to R3. So on R1, let's go into global configuration mode and then enter interface configuration mode for gigabit Ethernet 2/0. Once you're in interface configuration mode, since this is an IPv6 summary address, we'll type in IPv6. If you look down here in the output of help, it says summary address. So we use summary address. And then we have to attach it to the EIGRP autonomous system number. And then after that, we just simply specify our summary address. So I'm just going to go ahead and type in a random summary address here that ensures that, well, it's not really random. We are going to make sure that the 2001:A:12 address falls within the summary, or else the summary address won't be advertised from R1 to R3. So it's definitely going to include addresses that R1 has no idea about. It cannot route for either, but we're just doing this for demonstration purposes. So we'll just put :/60, and we should be good to go from there. So our neighborship should flap. I'm going to look at the IPv6 routing table now on R1, and can anybody remember what is created when we create a summary route? What is created? Yeah, the summary route's created, that's advertised over to R3, but what is created on R1 and put in R1's IPv6 routing table in this case? Yeah, look at that. For those of you who are saying a route to null 0, exactly. And what's the purpose of this route to null 0? The route to null 0 ensures that we don't have routing loops. For example, R1 has a default route, and that default route says if you don't know how to get there, send it to R3. So here's what happens. Right now, R1 is telling R3 about all these networks inside of this summary. How many addresses does that include? Well, originally, we have a /64. So take /64, and if you go to /60, what do you have? 64 minus 60 is what? 4. So if you take that value using our shortcut, that's 2 to the power of 4. That's 16 networks. Well, R1 only knows about 2001:A:12, /64. So there's 15 other networks, it has no idea how to reach. So what does it do? Well, when R3 sends traffic to R1 destined for 2001:A:0:0 /64 or 1:/64, what's it going to do with it? Well, without this route to null 0, it sends it back to R3 because that's what this route says. So then R3, because it has the route pointing back to R1, sends it back to R1, then R1 sends it back to R3. There's the routing loop. So this route to null 0 is automatically created to prevent that ping pong match from happening between R1 and R3 in this particular example. If we go over to R3 now, let's go over to R3, and if we look at R3's IPv6 routing table, we'll see the summary route is listed. And that summary route's being learned, or pardon me, that summary route is reachable via the next hop of FE80:13, which is R1's link local address, and it's reachable out gigabit Ethernet 1/0.